Hello everyone, my name is Ashutosh Naik, roll number 20EC10015 of section 12. I have made an anti-theft alarm system. The anti-theft alarm system can be helpful and even be life-saving in many cases. It can be used in houses, banks, lockers and many other places. The most interesting part is that it can be made with only few components and thus compact, which allows it to be used in many places. Coming to the circuit, I have used a PIR sensor, a piezo speaker, an LED, a oscilloscope, 3 multimeters and 1 resistor. The PIR sensor is connected to the digital pin number 2 and the 5-volt power supply. The piezo speaker and the LED both are connected to the digital pin number 13. The resistor has a resistance of 1 kilo ohm. The oscilloscope is connected to the LED and has a time per division of 1 millisecond. The 3 multimeters are connected to the LED, the piezo speaker and the PIR sensor. Now just look at the code. The digital pin number 2 is red. It can be either 1 or 0. If the value is 1, then the LED is set to high and the piezo speaker is played with tone 60. Now if the value of the digital pin 2 is 0, then the pin number 13 is set to low. It means that the LED and the piezo both will be turned off. Now we will start the simulation. We will see that if the person is moving, then the LED will glow and the piezo speaker will make noise. But as soon as the person becomes stationary, then the LED and the piezo speaker both will be turned off. We have seen that if the person becomes stationary, then both the piezo speaker and the LED are turned off. Now we will see that if the person moves out of the range, then no matter how fast the person is moving, then also the LED and the piezo speaker will be off. You can see no matter how fast the person is moving, the piezo speaker and the LED are off. Now we will look at the voltage across the PI sensor, the piezo speaker and the LED. As you had noticed, the voltage across the PI sensor was constant around 4.98 volts. The piezo speaker, it was around 2.05 to 2.15 volt, and along the LED it was around 900 to 950 millivolt. Now we will look at the current across all these appliances. As you would have seen, the current across the PIR sensor was constant at 50 milliampere. Around the piezo speaker, it was fluctuating but was approximately around 50 milliamperes, and around the LED, it was also fluctuating but around 2 milliampere. The oscilloscope was also showing that the current across the LED is fluctuating across time. Now when I was showing the current around the piezo speaker and the PIR sensor, it was not making sound and the LED was also not glowing because all the current was taken up by the multimeter and none of the current was passing through the piezo speaker. Now we will look at the code. Copy it. I have copied the code here. Now let us verify the code. As you can see, the code is correct and there are no errors. So that was it. Thank you.